Hello everybody, welcome back. This is Dr. Hussein again in Power Electronics. This is module number 4, week number 12. We will talk about industrial application. Uh, we already study power electronics converters. Let's see where we are going to use them. I will start with power conditioner and uninterruptible power supply. You need to know that yes, we generate electricity in the power plant. We convert this electricity from one shape into another using power electronic converters. But equality is an issue, an important issue here, crucial here. There are many disturbances could occur, okay, which affect the waveform, the type of power we are providing to our loads. I will give examples here about some of these disturbances. Over voltage when we have, let me say, voltage, normal one, and the voltage increase for a few cycles, we call it over voltage. Under voltage is reduced to few cycles. Outage when it is cut off, I mean the shutdown have occurred to the supply. Voltage spike, something spikes on the waveform. Okay, as we are gonna talk about it and show you the graph, the figures in the next few slides. Chop voltage, sometimes we lose part of the waveform. Example, when we have commutation, you remember when we talk about rectifier, we talk about commutation process. In commutation process, we lose triangle, small one. This is chopped, occurred in the waveform. Or harmonics, we discuss harmonics in rectifier and inverter and many other places. Harmonics is an issue, important issue. We need to reduce it as much as we can, otherwise the losses will increase, the power factor reduce, and we get many, let me say, effect on the load. And also electromagnetic interference, which is the high frequency noise occurred because of the switching, which affect the supply and the loads connected to that supply. See here, this figure, as you can see, okay, you can see here, this is just a minute, let me take the color. Okay, you can see here, this is a spike built on the waveform is this one, the normal waveform, as you can see here, sinusoidal waveform. This is the maximum value, this is the minimum value, but we can see here some spikes occurred. Okay, or sometimes the peak increased where we have increase in voltage. Okay, over voltage, under voltage when it go down, I mean you see here, this is the normal, it's reduced. Or cut off when we have shutdown in the supply. Now here, this one and this one, these figures are figures I just yes, a waveform, I measured them by myself in Sohar industrial area maybe 20 years back, and by using power harmonic analyzer. As you can see here, it's not pure sinusoidal. You see the voltage, you see the current. It's affected by many processes through the electrical circuits because of the load, but at the end, it affects other loads connected to the same supply. See here, we discussed the balance system. Balance system means the maximum should be equal, and the difference between each phase is 120 degree. But what happened here, you see the value, the maximum value are different for the three phases. This is called unbalance. Or sometimes interruption, as you can see here, it's get off. Or sag, voltage sag. This is the normal voltage is reduced here, as you can see. Or voltage swell, it reduced, as you can see here, from the normal. So these, or fluctuation, as example, this is RMS value. RMS value is supposed to be constant, but what happens is fluctuate, as you can see here. And sometimes they call it dip. It happened what we call it dip in voltage. The voltage suddenly reduced. We can feel this when the light reduced. It's happened because of, as example, motor started, and when motor started observe high current, starting current, 5 times the normal current, and this will reduce the voltage, and fluctuation occur when it's affect the light even as we can see. Or sometimes chopping. You remember this triangle, we lose it because of commutation. It's happened here, 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 some places. Or harmonics. You can see the waveform is not a pure sinusoidal as we usually want it to be. Now these surge also, transient and surge could happen, transient could because of switching, like capacitor on and off, charge, discharge. And also surge happen because of switching, many loads reduce, need to make surge, like spark, variable frequency speed drive, arc welding, computer, X-ray machine, MRI, and so on. Many applications will lead to these disturbances. Now we need to make sure that our load can handle the disturbances. and what we should do, what type of circuit we need to connect to make sure that it will not, the overload not affected by these disturbances. The sensitivity related to three important elements. The first element is the magnitude and power of the disturbance. We need to know what type and what is the magnitude and the power. The second issue is the equipment designed to consider this disturbance? And the third issue is there any power conditioner equipment connected to this to my load so it can protect it? I will give example here. You remember the power supply of the computer, PC computer, personal computer. When it get the electricity shut down, what happened to the personal computer? Uh, when it's back, you try to see that your data already recovered. How this recovered? Inside the motherboard of the computer, there's a battery, and this battery will, there's electrical circuit inside with sensor to sense the voltage. When the voltage reduce, this is the reduction in voltage, reduce below a specific value, the sensor will sense this and send a signal that there is something wrong with the supply. The circuit will work and try to provide the required power for recovering. This happens in milli or microsecond. You don't feel it, but the computer, the microprocessor will feel it, and the battery will provide power for this microprocessor to recover the data you've been working on. If we look to the nameplate of any equipment we deal with, we will find that there are many points related to the power quality. Example, voltage regulation, voltage disturbance, transient, over voltage, under voltage, harmonics and frequency. So any change, as example, frequency variation in this equipment, it is 60, the frequency, 60 hertz, but this equipment can handle up to plus minus 0.5 hertz to 1 hertz. So it tell you, as example here, voltage regulation, plus 5 to minus 5, 10, or sag, or under voltage, over voltage. It give you information. Many, let me say, equipment, in their nameplates, they consider some range of disturbance that they can handle. But the disturbance when increase, especially when we talk about industry, it reflects on the cost, on the economy. Example, in 19, this is data taken in US in 1992, a large, let me say, industrial customer company, okay, have 4 hours, as you can see, outage without notice. They didn't tell them that it happened suddenly. Within 4 hours, they use around $74,000. Or it happened once again, 1 hour, it cost them $39,000. 1 hour, but with notice, it cost them around $22,000. Voltage sag happened with them, it cost them around 7,000 something. And momentary outage shutdown, okay, for moments, it cost them around $11,000. So you can see when shutdown occur, over voltage, under voltage, harmonic spikes, fluctuation occurs, these companies lose money because I mean it disturbs their product. Now, to solve the problem of power quality and disturbance, what we need to do is to use what we call it power conditioner. Power conditioner is a circuit use power electronic converters, the converters we just discussed, to let me say make a conditioning to the uh, uh, to the um, to the power. It means clean it, reduce the disturbances, observe the disturbances. Example of this, I will start with the easy one, simple one, and then go to the more advanced one. You can see here metal oxide varstar. Okay, it's simple, and I will show you the photo for each one of them. It's used to reduce the effect of the spikes or observe it. Electromagnetic interference filter. It's filter. Today, most of the components, the receiver, TV, whatever, they have this electromagnetic interference at the beginning when they supply. And also isolation transform with electrostatic shield to make not only the isolation but to observe the spike. Vero resonant transformer also do something similar to filter. It's like filter, not only in isolation but also filter to reduce the line mode spikes. Or they use what they call it linear conditioner. It's a circuit with many sensors and It's let me say sense the fault, the type of disturbances, and then try to deal with it. These are, as I mentioned, the metal oxide varistor. These are the, you see here near the supply, okay, the plugs here, and these are, or this one, are the electromagnetic interference filter. These are the isolate transformer with electrostatic shield or ferroresonant transformer, as you can see here, or linear conditioner. Linear conditioner at the end with a circuit. Active filter as example. By the way, there is active filter, there is passive filter, there is different type. And there is hybrid, which contain active and passive. And active filter, it could be parallel, as you can see here, connected to the same point, PCC, point of common coupling, with the load, or it can connect in series through transformer, as you can see. I remember in maybe 2008, 9, I don't remember exactly, 11, I published this article. It's in Scopus in one of the journals. It's called Power Electronic, as far as I remember. I studied or investigated most of the, let me say, disturbances occurred, and focus more on harmonics and how we can mitigate them using different techniques. You can read about them in more detail there in this article. Now, electronic tap changer. Electronic tap changer, you know the transformer here, but we want output to be different voltage or to control the output voltage, as you can see here. So we have tap. In the past, it was done manually. Today, we don't need this. We use a triac, okay? Triac is like connecting two anti-parallel thyristor. You remember AC voltage controller? Yeah. Triac is giving the same effect. It's one piece, but it gives the same effect here. So triggering this one, it means this voltage appear across the output from here to here. Triggering this one, the voltage from here to here. Triggering this one, voltage from here to here. So we can control using AC voltage controller. Or what they use, sometimes they use uninterruptible power supply. Uninterruptible power supply is to make sure that my appliances or my equipment will not reach a moment where there is no supply there. How this work? Example, we have here the utility, the grid line, 50 Hertz as we say in Oman. Okay. Now it go to filter, sorry, rectifier, and the rectifier to provide charging the battery, energy to charge the battery, because we need the battery when electricity shut down later. Okay. At the same time, it go to inverter to back to AC with the filter to make sure that we have here clean on the critical load. We have a clean power. Okay, when electricity here shut down, the battery will take over and provide the electricity to the inverter, filter, and back to the critical load. For how long it will work, it depends on the load on the battery we are using. What is the banks we are using? Now, how we charge these batteries? I mean, the part I mentioned, how it work? It could be in this way. We have the supply here, go for rectifier, diode rectifier, and then isolating transformer to another rectifier in series, but controlled one. So we can control this one to make sure to control the charging, because charging need to be controlled. Or we may use isolating transformer and rectifier circuit with capacitor for filter, but here we use one of the DC-DC converters, step down as example, to charge the battery. Or we may use again rectifier with its filter, and then here any type of switch mode DC power